Okay.
Where do we leave off?
Points of inflection. Find all points of inflection of the function. 16. Y equals x cubed times 4 minus x. Now, what might I need to do first?
Distribute. Derivative.
Which one?
Distribute.
I would distribute first because otherwise I have to do a product rule and that just sounds miserable. But I can distribute and avoid having to do a product rule. So this is going to be 4x cubed minus x to the 4th.
Now derivative.
Now derivative. Y prime is
12x squared minus 4x cubed.
beautiful. Now what?
Second
We gotta
derivative.
take
Second derivative.
24x
Minus 12x squared.
All right, now points of inflection are points on the graph that has a tangent line and where the concavity changes. So we need to go back and basically check the concavity of it, okay, to see if it is changing. So how did we go about checking the concavity?
We did our little,
like the little like line.
we figured out,
Sign chart?
yeah.
Is that what it's called?
Yeah,
Yes.
Line chart.
sign chart.
Oh, sign.
All right, now what goes on there?
Constant. A number.
There are numbers.
0.
What numbers?
0.
Numbers.
I just
that-
throw a 0 on there.
No, you need like two numbers.
1, 0, and negative 1.
That's something else.
Well, don't we have to solve
That's
for, like,
plotting points.
X?
What are we solving for?
0.
We are solving.
How do we solve for 0? 0 is 0.
Figure out what
Setting
value.
equal to 0.
Setting equal to 0. What am I setting equal to 0?
X, like
The
24.
first derivative.
Second derivative.
Second derivative. Second derivative equal to 0.
Wow.
If x is equal to 0. Right?
So
Then
now
it
what you
equals
want to
0.
do is
Well, that's one option, but how do we find that?
by
How do I solve for x?
Take out.
Or like not solve for x, but how do I like
Let's take out
Let's
12x.
factor out, yeah, factor out that 12x.
I don't know what I'm doing, I swear.
Just lazy.
Minus
X.
Wex?
I didn't say that.
Like the dinosaur from Toy Story?
Wax.
Now what?
So
now
now
you can
we
set
set both
each
pieces to
piece to
equal to the 0.
So
And so
you kind of know.
x equals.
I do know how to do the
She
rest.
does. Correct.
I assure you I know how to do the rest.
So x
That's
would
good.
be equal to 0, and x would also be equal to negative 2. I mean positive 2. It's
I
positive.
was gonna ask. I know what to do. I don't know if y'all do, but
What do you know?
Mostly.
Well, sometimes the math just like doesn't math.
you don't have Peyton to be like, you're doing it wrong.
Exactly. What am I supposed to do?
So like now we can do the line. Oh, you already did it.
So now we have to
Pick
Plug-
values on like each side of 0.
we plug it into the
into.
original or the first derivative? The first derivative,
You
right?
plug it into
Concavity is what?
y double prime.
into double prime. Okay, the sign of double prime is what I'm checking.
Right.
So, if I put in -1,
You would get
Negative.
negative. How about 1?
put in a 1, you would
Get
positive.
positive.
Positive. Be positive.
Yes.
So like if you put in a 3, I think you would be getting a negative.
Negative. I knew it was negative, but yet my mouth still went to say positive. I'm tripping.
Wait. Yeah.
Alright, so points of inflection occur where the concavity changes. So is concavity changing at each of these points?
Yes, it's changing from
It's going
-1 is
going from min to max or something.
It's negative to positive to negative. So concavity changed at each of these
Oh,
points.
okay, yeah.
So
correct.
now I take these and I plug them into the original to find the point of inflection. So concavity changed, which was the indication that they are points of inflection. Sometimes it will stay positive. Okay, if it just stays positive, that's not a point of inflection. So that's why we have to check. So we plug these values into the original. If I plug 0 into the original, I get
0.
0. If I plug 2 into the original, I get, might be easier to do it in this one.
$16.
16, so I also have a point of inflection at 216. So these would be the points of inflection that they are looking for.
Okay. So we're basically just doing what we did with concavity, just finding the points.
Right, so that's what I was saying the other day. When we did the concavity problems, I don't really know why they didn't just have us finish it. Because you have to do everything up to that point anyways.
Right, okay.
Because we started out this section doing the first derivative test, which is when we were doing the sign chart, but we were plugging it into the first derivative. Concavity goes into the second derivative. Points of inflection, we have to do everything up to concavity, meaning second derivative. But then once we have those points and we verified that the concavity changes, we have to take those numbers and plug them into the original to find the actual points of inflection from the original graph.
Okay.
Let's look at one more of those just to make sure that we're good on points of inflection. And I mean, it's good practice for concavity as well. Y equals x to the 1/2 times x plus 3.
Let's
Should we
distribute
distribute?
that.
So,
So what would that be? X to the 3 over 2 plus 3x to the 1/2.
Oh, I have to, so, let me pause for a second. So I was teaching inverse functions today in one of my classes, and we were trying, the original function was this, okay? And when we took the inverse, we found that the inverse was, okay? So I said, what do you notice about these? What do you think they said?
they're the same.
No. They said, one's slanted. I was like,
Well,
What?
okay, well, you're not wrong, but that's not relevant. So I had to rewrite it so that they could disregard that. Anyways. So anyway, when I was writing the fractions, it made me think of it. It was just... Gotta love it. That's what happens with math first thing in the morning. All right. So now what with this problem?
Now we find the derivative.
Which is?
3 halves x.
Negative five halves. Wait.
What?
No, it's 1 half, isn't it?
1/2.
Yeah.
I was like, where did you get that from?
So, and then,
You were doing
I was-
antiderivative.
Yeah.
And then it said, like, that would be 1.5x.
How about we just write it the same way?
No,
Okay.
don't do that again.
He just really doesn't like.
Negative half.
There we go.
I'm gonna start almost the same. Load.
Now you gotta take that
Second derivative.
second derivative.
So, in theory, this would be 3/4 x to the negative half plus negative 3/4 x
to the negative. Wait.
negative 3 halves.
Oh.
It's been up there for a while, so.
I was just gonna let him have that one. All right. Any suggestions?
I suggest that we set the derivative equal to 0.
Okay.
I suggest.
Sounds like a great plan.
And then, okay, so we can take out
I don't know.
a 3/4 x to the negative half. Whatever that be.
I was gonna let you tell me.
Wow. So 1 minus
1 minus x
to the 1. To the negative 1. Wait.
to the negative 1 over 2. The negative 1.
Why would it still be negative 1? Are we taking out the negative?
I'm just 1 second.
Oh, okay.
Whatever. I was trying to. It made this one like perfect. I was trying to make this one perfect, and it wasn't cooperating. I got sidetracked. But you're not taking out a negative. You've taken out.
You're just taking out.
You're like subtracting it away.
Okay.
Because when you plug it back in, you have negative 1/2 plus negative 1. When you
Okay.
multiply them, it adds the exponents back together.
Right. Okay. I understand. So again, set both pieces equal to 0. Right. Right.
Yeah.
And I would recommend we do this.
Right. I would also recommend that. I was actually gonna do that. Definitely.
Because why?
To make it easier.
Well, what's going to be the issue here?
Well, you can't have a square root at the bottom. But like,
Well, sort of. I mean, yes, correct. But what's the issue?
Undefined.
It will be undefined when.
When x equals 0.
And
When x
When x equals.
I almost just said negative.
16.
what?
Wait, no, I think it was one.
What's also a problem with a radical? What causes a problem?
And negative.
A negative. I was about to point to my little dude up there on the wall.
The what?
The little dude on the wall.
Where?
Look up.
Oh, I was like, what are you talking about?
What are you pointing to?
I was like, what are you pointing to? The
The
poster.
dude on the wall.
I thought she was talking about something on the iPad.
All up there.
I was too. I thought you were pointing to the top of your iPad. I was like,
Bruh.
I don't see anything.
Okay, so negatives are also going to cause a problem.
Right.
Okay, so that means I can't have anything less than 0, right?
Less than 0.
For that, because it's going to cause an issue. So, there's nothing that makes it 0. However, there is stuff that makes it undefined. Because 0 on the bottom is going to make that 0, and any negative numbers are going to make it undefined. Now, what about this one?
Okay. Well, if x equals 1,
obviously.
X equals 1 is going to be a problem. Or it's going to make it 0, sorry. What's going to be a problem in that one, though? 0. So x equals 0 is also a problem in this one. It's a problem here and here because it makes it undefined. So, what might I need to do?
You gotta.
but for 1, you're on.
So I'm going to put 0 on here, but I can't have anything over here in this area because it's going to cause an undefined situation.
Right.
0 can't really be anything because it's just an end cap, basically, or not. It's not even an end cap because we can't have 0. We can get really close to 0, so it's actually going to end up being an asymptote. But I'm still going to look in between because in here, if this changes between these 2 points, okay, then my concavity changes and I'll have a point of inflection. Okay, so between 0 and 1, what might we pick? 1/2, and this is going in y double prime. So if you put 1/2 up here, we might want to think about it as, we might want to do this.
Yeah,
Like that. And then you might just want a calculator, potentially.
It'd be negative.
Think I agree with you. I don't know what the square root of 1/2 cubed is.
1/16.
Christian, did you get a number?
Yeah, it's negative on my calculator.
Okay. Sweet. Alright, what about over here?
Let's use a 2. So. Oh, wait, actually, I want to use something that.
I was gonna say, maybe use like 4. Might make your life a little easier.
Yeah. 4. Wait.
Positive. So, it's like life would have actually been a little easier if we'd used 1/4 instead of 1/2. Square root of 1/4 would have been 1/2. Would have been a little easier to work with. But, anyways. Okay, so concavity changes. So, point of inflection. This is mine now. So, at 1, so if we plug 1 into the original's up here, what do we get?
You said 1.
It's like
1 into the original.
Like,
1
2?
is half is
What's the square root of 1?
1.
What's 1 times 1 plus 3?
4.
Okay. Alright, so your point of inflection is at 1/4, so like that one only had 1. Okay, 0 was just there as a marker so that we knew we couldn't pick a number on the other side of 0, basically, because that would have caused an issue. Okay.
Wait, but why was it? But it was 1 to the 1/2. So why was it?
What's the square root of 1?
1.
Isn't the square root of 1 equal to 1 to the 1/2?
Is it?
Yeah.
Okay, cool. Just making sure. All right. In exercises 25 through 28, a particle is moving along the x-axis with position function x of t. Find the velocity, acceleration, and describe the motion of the particle for t greater than or equal to 0.
Derivative?
So we're basically doing the exact same thing we just did. Let me see if they have an example we can actually look at really fast before. Do they not have an example of this? Hold on. Oh, okay. Look at example 5 on page 213. Because this involves, it's not exactly a word problem, but I mean it kind of is because we're looking at I'm hesitant to do this because I feel like it's just going to end up. Okay. Alright, so we start out with a particle is moving along the x-axis with position function, and they give us all this information. It says t greater than or equal to 0 because obviously we can't have negative time, so that's going to be the stipulation on all of these type of problems. Find the velocity and acceleration and describe the motion of the particle. So that's exactly what we were looking at, or that's exactly what our problem is asking us to do. So they have taken the derivative to get velocity, okay, the velocity function, and they've just rewritten it such that it's easier to work with. They've gone ahead and factored it out. Then they get the acceleration function, so they take the derivative again, which is the second derivative of position. Okay, and they do the same thing. They factor it out, so it's easier to work with. When the function x of t is increasing, the particle is moving to the right on the x-axis. When it's decreasing, it's moving to the left. Okay, so they do the same thing with this sign chart here to determine what's happening. So, notice the first derivative is 0 and t is 1 and t is 11 over 3, which they were able to find because of that information up there, because they had already factored it. So then these zeros partition the t-axis into 3 intervals as shown. Now, we block off 0 because we can't have negative time. So then we check the velocity function. Okay, we check the values in the derivative, the first derivative. Okay, and then if it's positive, it's increasing and moving right. If it's negative, it's decreasing, moving left. And well, it's positive again. Okay, so it's positive, negative, positive for that. So that's the first part. So then the particle is moving to the right at the time intervals from 0, and notice they capped 0 to 1, and then it's open, and then from 11/3 to infinity, and then it's moving left from 1 to 11/3, and notice those are all open intervals there. Then we've got let's see, acceleration. We have that function, so t is, or 0 when t is 7/3. So then we check it in the second derivative here. And so at that point, it's concave down when it's negative, concave up when it's positive. So concave down is decelerating, so down is decelerating, if that helps you. Up is accelerating. And so the accelerating force, oh gosh, I can't see it, is directed toward the left from 0 to 7/3, and they are capping that, and then it's momentarily 0, and then it's right after that. So basically, what I would ask you to do is just basically to do these sign charts and just right below them just how they have it of what's happening in those intervals. So that's essentially what we're going to do for these problems. So they're not really any different than what we just did, other than having to explain which way they're moving and if they're increasing or decreasing. It's really the only difference with that. So let's look at one of those. Let's look at 28. X of t is equal to 3t squared minus 2t cubed. All right, so we need to find the velocity and find the acceleration. I'm going to probably do velocity and then finish out with the first derivative with their sign chart, and then take the second derivative and do that sign chart just to keep things flowing a little nicer when all together, or I might do them side by side. I don't know yet. Anyways, so the velocity function is the derivative of position. So what is the derivative of this?
6t minus 6t squared.
Okay. And then we're going to be setting that equal to 0. I think I'm just going to do acceleration beside it so we can, anyways. So now what do I do over here? I'm going to finish out velocity and we'll move to acceleration.
Factor out a 6t.
And so that'll leave us with 1 minus t. So what values of t make it 0?
T equals 0 or t equals 1.
Yep, now, we already know that time has to be greater than or equal to 0 because we can't have negative time. So that 0 is just getting thrown on there, basically, because that's, you know, an endpoint anyways. But we still put it on there. So basically now our sign charts just look slightly different because now at this point here, there is 0, and then we're going to have 1 here. And so in v of t, okay, this is the sign of v of t. When we plug the number in, if I plug in 1/2 to this, what happens?
It comes
Is it negative? I think it's positive.
It becomes
Which one are we plugging in? Which one are we plugging into?
Plugging it into here.
it becomes
Because, right, 1/2. No, yeah, we do.
It's positive. Because if you plug in 1/2 here, that would be 3. If you plug in 1/2 here,
And I get
that's going to end up
1/4.
giving you 1.5. So then 3 minus that was going to be positive.
Right.
So positive in here. And we'll write what that means in just a second. But for right now, we're just going to write positive. And then over here, if I plug in 2,
Negative.
negative. All right, so positive is increasing. Okay, so it would be increasing, and it would be moving to the right. Okay, so this is exactly as you would think it would be. Negative is decreasing, and it would be moving left. So that now, taking the second derivative of the position function, which is also known as acceleration, which is the derivative of velocity, and so what would the derivative of this be?
That would be 6
Now what?
minus 6.
You can do
Wait.
that, or you can just, since you only have one term with a t, you can just
Set it
move it over.
up. Very
-12t to -6. So then t would be 1/2. And then we do the same thing, except for it is going into the second derivative this time. So we still put 0 on there because obviously still can't have 0 time. And then we would have 1/2. And this is going into the sign of a of t.
Ew. Ew, this is gross.
But fortunately, like, I would say pick like 1/4.
1/4.
Because 1/4 is in there and that number's going to cancel nicely with 12.
Okay, so that one's gonna be positive.
You used 1/4 for that one.
Yeah.
And then the other one we
Let's
will
just
use 1,
What
which will be negative.
do we just
So, when it's positive, it is concave what? Up. And that means it's doing what?
Increasing. Decreasing.
Decreasing.
Oh.
Oh, it's increasing.
That was over here.
Increasing.
So what's
Wow.
decrease?
What am I discussing here?
Acceleration.
It's slowing down.
So it is
Speeding up.
Increasing left.
accelerating.
Yes, you're right.
It is accelerating. So over here, what's happening in this one? It is concave. It's decelerating, and it is concave
Down.
down. Okay, remember, down is decelerating.
It's not even that
I was gonna say, you can't use that excuse, it's not Monday. Thankfully, it is only a 4-day week, though.
I think my waking up at 4:45 is catching up to me.
That's fair. Go home and sleep all night like you did last week. Alright, are we okay on that? Really, the only thing different on these than what we did on the other ones is the phrasing at the
I
bottom.
think we can.
I'm okay.
Okay. Let's see. We got something wild and crazy here to finish with, I think.
Wow. Wow. Slow down.
Something wild.
Decelerate for us,
Don't-
please.
Don't get
Don't
Don't
get crazy.
crazy.
I feel like people that just like randomly like listen in, like not that anybody does, but if people did, I feel like they would be so confused on what was happening.
They'd be trying to just do math and
they'd be missing out.
All right, 36. These ones say use the second derivative test, which we've fortunately been doing for 2 sections now, to find the local extrema for the function. So I'm going to do one that's a little harder than what we've been doing, Just so that,
Yeah,
Just so that we can say we did it.
yeah.
so that we understand.
Let's not say we did. 3x to the 5th minus 25x cubed plus 60x plus 20. Man down.
Okay, okay.
All right, what is my first step to finding
Derivative.
local extrema?
Derivative. So 15x to the 4th minus 75x to the 2nd plus 60.
Plus
Okay, now what?
now you
Second
want to take that
derivative.
second
Okay,
Go ahead and do that.
I'm gonna write this over here.
Yeah. Which is
60.
60x cubed minus 150x.
Okay,
Now we set the second one equal to 0.
Wait,
No, we set the first derivative equal to 0.
first one equal to 0.
Yeah.
okay.
Because what is that gonna tell me?
Is it gonna
It's
tell
gonna
you?
tell you your points of inflection.
Nope, that's
no,
what we
it's
just
gonna tell
did.
you your points of contradiction, not contradiction.
No.
Your points
Of constriction, no.
It does start with a C.
Point of
Con-
condemnation.
point
Ethan,
of
do you know what by taking the first derivative and setting it equal to 0 tells you?
the point
What are they called?
of-
You said what again?
When you set the first derivative equal to 0 and solve, what points does that give you?
It's not inflation.
No, inflection's what we just did. This is back from 5.1.
Oh, this sounds like a critical question here.
Critical point.
Thank you. Critical points.
Good job, Christian.
Christian just needs to speak up.
I wasn't called on, so to be fair.
None of us were. We just kind of.
I just called on Ethan because normally he knows and he's sitting over here cracking up at y'all that don't know.
How were you laughing at us?
He wasn't this time. All right, so I'm going to set this equal to 0. How do I solve this?
You just just
Literally-
you can, like, it's a special type, isn't it? Wait, you could like
You can, well, Nathan, you can take a 15 out.
Okay, okay.
let's try that.
If I take a 15 out, what do I get?
Then you have
15
x to the 4th minus
three.
Nope.
no 5
That is 5.
x squared
5x
plus you got this one.
yeah 4.
Now, because that 15 was going to go away when I took 0 divided by that, I just didn't write it. Now what? Who are you blowing kisses to?
William Showalter. Did you leave one night or
We can do it again. I think. They can't. Well,
Let
in
us
theory.
All I see is I've never seen Christian that where he's like,
Well, I drew a turn table.
Yeah. No, we get it, Christian. We get it.
I had to know what was happening.
So
Okay.
Now you can
Now you got a factor.
look. So factors.
Factoring
of
sounds like a great plan.
4 that equal 5,
Why is
negative
this
5.
so
So you can do negative 4 and negative 1. How about
Okay, how do I write this?
Okay, we can do it. So
I'm sure we can. How?
wait, let me write it first.
Sounds great. Factor that.
Okay. X to the 4th minus 1x minus 4. Wait, no, that wouldn't work.
They both have to be negative. So it'd be
Yeah.
negative 4x plus negative x.
But then that would just give you negative 5x over 5x squared. Maybe if you like.
Wait, why is the 5x squared? Oh, because,
Christian?
Like
I
factor
wasn't paying
out.
attention. What?
So,
Oh,
negative,
sorry.
negative
It's
4x.
like negative 4 and negative 1.
I know that. Yeah.
Negative 4x squared minus x squared.
Okay, so we can do it that way if you want. That's fine. I was gonna do U substitution, but if y'all want to do it that way, that's
I
fine.
wouldn't even
I need a
substitution,
review on
I
U
don't even
substitution.
remember.
Okay.
Like, I'm gonna be
U substitution. Let U equal x squared. So then I've got u squared minus 5u plus 4 equals 0. Now I can factor the way you were saying with a -1 and a -4. So u squared minus u minus 4u plus 4 equals 0.
And that makes it easier to.
And it makes it easier to break down. So factor out a u minus 1, -4, u minus 1. So then I've got u minus 4 times u minus 1. At this point then, I'm going to replace u back with x squared. So I'm going to go ahead and split it just to save a step of writing. So x squared minus 4 equals 0. X squared minus 1 equals 0. So then I've got x squared equals 4. Take the square root
X equals 2.
and
Oh, and the other one, x equals.
positive and negative.
thank you. Positive and -2. X equals, or x squared equals 1, so x equals
Positive and -1.
positive and -1.
Why do you have to do that, though?
Because when you take the square root, you have a positive and a negative value.
I don't like that.
It's been that way since Algebra 1.
And I've always
It's been a
hated
while
it.
since we picked them out.
Oh, we've done this more recently than that. I'm just saying it's been that way the whole time.
Remember.
Okay,
I really.
the bell's gonna ring shortly, but what do I do now? These are my critical points, right? I have 4 critical points. Was I given any endpoints? No.
No.
So I'm gonna check all the critical points, right?
You gotta check
Yeah,
all
yeah,
the
check 'em out.
Okay, so my second derivative we have up here. I'm going to do it up here just so it's easier. So we're going to take f double prime of -2. So we're going to plug the numbers in to that and see if it ends up being positive or negative. Okay,
Okay.
we're going to do f double prime of 2, f double prime of -1, and f double prime of 1. Okay, and then we're going to see, all I really care is if it's positive or negative. Okay, and go from there. Now, because we're about to run out of time, this one at -2 is going to be -180. At 2, it's positive 180. At -1, it is 90. And at 1, it's -90. So, less than 0 means what?
Oh, it's.
Max.
So there is a local max x equals -2 and a local max at x equals 1, and then we have a local min at x equals 2 and a local min at x equals -1. Alright, I need to give you all your problems really fast because I won't be in class tomorrow. Alright. 1, 3, 7, 13. 17 is going to be a little bit harder like number 18 was, so just be aware of that. 27 and 35. I think that covers everything we did. Now, it's not due till Friday, but maybe I should say Thursday, because that way you can have questions on Thursday potentially for me for the quiz for Friday so we can review.